Hello Year 12s, I hope you and your families are well and safe. Welcome to another lesson. The title is The Geometric and Uniform Distributions. So of course last week we completed the binomial and Poisson distributions subtopic, and today we will continue talking about the geometric distribution before moving on to the uniform distribution. So just to remind you of what a geometric distribution is, well, it's similar to the binomial distribution. However, it is the number of trials until we get our first success. So here is some information. Of course, feel free to go to last week's lesson where we discussed the properties of the geometric distribution in a bit more depth. So here we have a geometric distributions example. For a particular board game, a double must be obtained by throwing 2 dice before a player can start. Find the probability that a player starts within 4 attempts of throwing the 2 dice. So in this example, well, we have to think about a double being obtained when throwing 2 dice. So a double is when you throw 2 dice and you get 2 1s or 2 2s or 2 3s or 2 4s or 2 5s or 2 6s. So there are 6 different doubles we can obtain, and when you throw 2 dice, there are 36 outcomes in total, because you can get 6 and 1, 6 and 2, 6 and 3, 6 and 4, 6 and 5, 6 and 6, so on and so forth. So yeah, 6 times 6 is 36. We can simplify this fraction to get 1 over 6. So it says find the probability that a player starts within 4 attempts of throwing the 2 dice. So a condition for in order for a player to start is throwing a double. So I'm going to write let x equal number of throws of a dice, of course, until a double. Because remember, a double is the success in this particular geometric distribution. So I'm going to write x is geometrically distributed. The probability of 1 over 6. So that's the probability of success. So within 4 attempts, that means they have had their success in their first attempt, second attempt, third attempt, or fourth attempt. So now I'm going to write probability that x is less than or equal to 4. Well, of course, that equals sorry. So if they have achieved a success in their first attempt, then the probability is just p, so 1 over 6. If they have achieved it in their second attempt, then they've had the success on their second attempt, but they had a failure in their first attempt. So p multiplied by the probability of failure, which is 1 take away p. Success on the third attempt, but they've had 2 failures, right? So it's 1 take away p squared. And using the same principle, we have 1 take away p cubed. And so now we just substitute the 1 over 6 into where you can see all the p's. So it would be this 5/6 squared. Oh, sorry, the last one should be cubed. Right, so using a calculator, we get 671 over, and if we were to write that as a decimal, that is 0.518 to 3 decimal places. Now I'm going to also show you a shorter method to work out the same question, to one of the questions we worked out together at the end of last week's live lesson. So the probability that x is less than or equal to 4 is the same as 1 takeaway probability that x is greater than 4. So 1 takeaway. Now, probability that x is greater than 4, well, now in terms of what that actually means in this specific example, this is the probability that no doubles are achieved within the first 4 throws. So right, no doubles in first 4 throws. So in other words, we have had 4 failures, right? 4 failures in a row. So 1 takeaway, the probability of failure is 5/6. So right, 5/6 to the power of 4. Now if you were to type that into a calculator, you would get the same answer as we got in the previous slide, which is 671 over 1296. You may have seen on the first slide, we also need to be able to understand and use the mean and variance of a geometric distribution. So we will start off by doing a proof of the mean of a geometric distribution. So we know that expected value of x is all the x values multiplied by their corresponding probabilities . So we have x multiplied by all of this is replace with q, or minus q I should say. So p is the same as 1 take away q, and 1 take away p is the same as q. Now we have q to the power of x take away 1. Oh, I forgot on the x here, sorry. Okay, so let me just quickly do this. So 1 take away q, x, q, x take away 1. So on the next line we write x, q, x take away 1, take away x, q, x. So I expanded brackets on this last step. Okay, I'm going to separate the summations now. And I'll write x equals 1 . x equals 1. Now, before I continue this proof, I like to say that the mean and variance will be given to you in your exam formula book, and it is important for you to follow what is going on here, but you won't necessarily be asked to do this in an exam. So now, continuing with the proof, I'm going to change my limits slightly, my index, sorry. So I'm going to change it from x equals 1 to x equals 0, and yeah, the infinity stays the same. But now that I've changed that, I need to change the values to the right of the summation as well. So here we have an x, and since we start at x equals 1, we want our first value there to be 1, right? So here I need to change it to x plus 1. And we have q to the power of x take away 1, which means the first x take away 1 will be 0, right? Because it's 1 take away 1, which is 0. So here, since our new starting point is at x equals 0, our index will be just x. And for the second summation, we need to look at it carefully. We start off at x, q to the x, and I'm actually going to keep that the same. Now, the reason why I'm going to keep that the same is because the first term in this summation will just be 0, because if you sub in x equals 0 into here, you get 0 multiplied by q to the 0. And so actually, we don't actually need to change anything there. Okay, what I'm going to do next is bring them back to one summation. So x plus 1 q x take away. Since the limits are the same, I am allowed to do this. X, yeah, equals x q x plus q to the x. Here we x q to the x, right? Now, as you can see, these two cancel out, so we are left with q to the x, which is a geometric series. And so it is the same as, so that summation is the same as 1 take away the common ratio, which is 1 take away q. And so that's the same as saying 1 over p. So this is what I used for that last part. Now I know that you probably haven't learnt about this yet, so don't worry about it too much. We will learn about it soon. So this is the information I'd like you to copy into your books. As I said, it will be provided to you in an exam. Here we have an example where we need to work out the mean, variance, and standard deviation. The probability that a pool player puts a ball on the initial break of a game is 0.4. So we can already say that x represents how many games it takes for a pool player to pot a ball on the initial break. So, alright, number of games until pool player and so x is geometrically distributed with a probability of success of 0.4. Find the expected number of games, corresponding variance, and standard deviation before this player first puts a ball on the initial break. Okay, so the mean is 1 over p, so 1 over 0.4 2.5. So on average, we expect a success every 2.5 games. The variance is, again, using the formula 1 take away p over p squared, at 0.6 over 0.4 squared, which equals 3.75. And the standard deviation is the square root of the variance. Which is 1.94 to 2 decimal places. Discrete uniform distribution. So the standard discrete uniform distribution takes values 1, 2 up to n. As you guys know, uniform distribution means that each outcome has the same probability. So for example, rolling a fair six-sided dice, the probability of getting a 1, 2, 3, 4 up to 6 is going to be 1 over 6. They're all going to have the same probability. So here we have a table which demonstrates what I have just said. We have our outcomes at the top, the probability of each, which as you can see is the same, 1 over n. X multiplied by the probability of each will be 1 over n, 2 over n, and so on and so forth. And x squared p will be 1 over n, 2 squared over n, 3 squared over n, and so on and so forth until n squared over n. So now we are going to do a proof for the mean of a discrete uniform distribution. The mean and variance will be provided to you in an exam formula book. However, you also need to know how to do it yourself as well. They may ask you to do a proof for the mean or variance of a discrete uniform distribution. So we know that sum of all the x's multiplied by the corresponding probabilities going to be x multiplied by 1 over n, because each corresponding probability will have a probability of 1 over n. So 1 over n is a constant, so I can take it out. And if you remember from our sequences and series topic, this type of summation is the same as a half n plus 1, right? So right here. And so now, out, and we are left with a half n plus 1. We know that the variance of x is ex squared, take away the square of ex, so is sum of all the x squared terms multiplied by the corresponding value, the corresponding probability. So similar to the previous slide, I'm going to take out a factor of 1 over n. I'll write x squared here. Now again, from the sequences and series topic, we know, and actually this one appears in your exam formula booklet, sum of all the values, all the x squared values is the same as 1 over 6 n multiplied by n plus 1 multiplied by 2n plus 1. So again, this cancels this n, and so we are left with 1 over 6 n plus 1 2n plus 1. Is ex squared, take away ex all squared. So we proved this on the previous slide. So 1 over 6 n plus 1 2n plus 1, take away this squared, so I'm going to have 1 over 4 and n plus 1 squared. I'm going to rewrite these two fractions so that they have the same denominator. So 2 over 12 n plus 1 2n plus 1, take away 3 over 12 n plus 1 squared. So I'm going to take out a factor of 1 over 12 and n plus 1. So I'm going to open brackets here. 2n plus 1, take away 3, just n plus 1. So we have 4n plus 4, take away 3n, take away 3. So we are left with 1 over 12 n plus 1, n take away 1, yeah. So we have a difference of 2 squares here, n plus 1 multiplied by n take away 1. So we can just write n squared take away 1 instead of writing both of those binomials. So here we have all of that useful information on one screen. If you haven't done so already, please make sure you write these down, highlight it, put a box around it, because it is key information. And please do that for all the key information from today's lesson and the last few lessons, of course, if you haven't done so already. Here we have an example. Work out the mean, variance, and standard deviation of the score when rolling a fair 8-sided dice. So this fair tells us that the dice is uniformly distributed. So we have an 8-sided dice, so I can say n equals 8. So the probability of each of the outcomes will be 1/8. The mean will be n plus 1, which is 8, n plus 1, so 9/2, which is 4.5. Variance will be a half, n squared take away 1, eight squared take away 1. So that is 63/12, which is 5.25. And the standard deviation, we use the mu symbol, of course, for standard deviation, is the square root of 5.25. Which is to 2 decimal places, 2.29. I would like you, for your independent task, to complete the rest of exercise level 1. That's questions 2, 3, and 4. Remember, the answers are on integral maths, so please make sure you mark your work after you do it, of course. And then also, I'd like you to do exercise level 2, the rest of exercise level 2. So that's questions 2 and 3. Also, please mark your work. And yeah, make sure you submit your work through the Teams assignment. And for next week, I would like you to submit your discrete probability distributions topic assessment. Please submit them as PDF documents, because it is a lot more difficult for me to mark photos as opposed to PDF documents. So yeah, if you have any questions, please make sure you email me or speak to me through Teams. I would also like you to refer to our previous few lessons as well to make sure you're not forgetting any of that information. We have covered a lot of information these last few weeks, and I know it's more difficult with remote learning, so please make sure you're constantly referring back and asking me if anything doesn't make sense to you. I'll do my best to help you. So yeah, thank you for listening, and I hope that you benefited. I hope that this made sense to you. So yeah, take care, and I'll speak to you soon. Bye bye.